Hello friends, Mr. Burrell here. We're in the middle of this last trigonometry unit. We just have talked about, so far in this unit, we've talked about finding the area of oblique triangles. We've talked about using the law of sines to solve for missing sides and angles of oblique triangles. And now we're going to talk about the law of cosines to help us to, you guessed it, solve for missing sides and angles of oblique triangles. So this is the last section in this unit that we're going to cover, and then in the extra, we'll have some extra stuff that we're going to go over where we'll go over some real-world examples of where we use the law of sines and the law of cosines. The law of cosines is another one of those things that often pops up on the ACT, which is a big reason of why we go over it, and it's really practical in the real world. You'll see some of those examples in the next extra module. Okay, so by the end of this video today, this is what I hope you're able to do. I hope that you know the law of cosines and that you're able to use the law of cosines to find a missing side length and use the law of cosines to find a missing angle. And we'll talk about how to do that here in just a moment. So in the last video, we talked about the law of sines, and we were able to use the law of sines to solve for missing angles and sides in oblique triangles only when I knew at least a side and an angle opposite that side, because that's what the law of sines is. It's a ratio between a side and the sine of the angle opposite that side. But what about when I don't know at least one side and an angle opposite that side? What do I do? Maybe this situation, for example. I have like a side, angle, side situation. So I have this angle, but there's no way right now of knowing the side opposite that angle. What do I do? Well, never fear, because we have something for that. And, again, you guessed it, it's called the law of cosines. So when we have a situation where we don't have an angle and a side opposite that angle, and we can't use the law of sines, we use the law of cosines in order to solve for missing sides or angles. So, in the situation, like on the previous slide, where we have a side and an angle in between, a side, angle, side. Here, right here, is the law of cosines formula. So where A, B, and C, lowercase a, B, and C are the side lengths, and big A here, and big C, and big B are the angles. So in this problem, what it says is if I know this side, this angle, and this side, and I'm trying to find this side right here, this is the law of cosines formula. A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. So, if I have two sides and an included angle, the law of cosines says that this side, the side opposite the angle given squared, is equal to this side squared plus this side squared minus 2 times this side times the cosine of this angle. That's why it's called the law of cosines. So A squared equals B squared plus C squared minus 2BC times cosine of A. It's kind of a long formula, that's why I'm giving it to you. And these right here are just variations for the different sides that I would be trying to find. So if I was trying to find side B, I'd take A squared plus C squared minus 2AC times the cosine of B, that angle opposite B. If I was looking for side C, then C squared equals A squared plus B squared minus 2AB times the cosine of C, that angle opposite C. If I didn't know any angles, never fear, I can rearrange this law of cosines formula to solve for A. So if I don't know any of the sides and I'm trying to look for an angle, then cosine of that angle, say angle A, would be B squared plus C squared minus A squared, so subtracted by A squared, that side that's on the opposite of that angle, divided by 2 times B times C. And again, these formulas right here are just adaptations for these different specific angles. So all of these you can use. If you have my guided notes and these formulas are on there for you, use them. Keep them close by. If you don't have the guided notes printed off, I would write these down somewhere on your mirror, on a sticky note, on the back of your eyelids, somewhere where you'll remember. Questions like this on the ACT, they would give you this formula. We just need to know how to use it. So we'll go over some examples here in just a minute of how we use the law of cosines. But before I do that, I want to show you kind of a cool relationship, something that I find pretty interesting. So right here, I have a right triangle. Side A, B, and C. I have a right triangle, so if this was a right triangle, this is not an oblique triangle anymore, it's a right triangle. It means this would be the hypotenuse. So, just bear with me here for a minute. This triangle would utilize this formula right here. Say I knew side A and side B, and I know side C is 90 degrees. Say I was trying to look for side C. Then C squared would be equal to A squared plus B squared minus 2 times A times B times the cosine of C. Well, C is 90 degrees. C is 90 degrees. Well, go ahead and type in your calculator or look at your unit circle. What is the cosine of 90 degrees? Well, it's 0. So that means C squared equals A squared plus B squared minus 2 times A times B times 0. Well, negative 2 times A times B times 0 is 0. Does this look familiar to anyone? A squared plus B squared equals C squared. That's the Pythagorean theorem, is it not? That, by golly, is the Pythagorean theorem. We learned that a long time ago as a way of finding missing sides of a right triangle. So look at this. The Pythagorean theorem is just really a special case of the law of cosines when this angle is 90 degrees, or a right angle, which just makes all this last stuff 0, leaving you with the Pythagorean theorem. Whoa! Mind blown! I hope that your mind is blown at home, because that is crazy. That's insane. Okay, anyways, this is the law of cosines. We're going to talk about how to use it. Okay, so here we say the instructions are find each measurement indicated, round your answers to the nearest tenth. So notice here I have a side, an angle, and a side, so I cannot use the law of sines. If possible, I would want to use the law of sines because I think it's a little bit easier to look at, more visually appealing than the law of cosines. It's easier to compute, but we'll start by using the law of cosines. So I want to find this side over here. Side length AC is, if I'm using my little letters, is side B. So I'm going to go to my law of cosines formulas. When I'm trying to solve for a side, I have B squared equals A squared plus C squared minus 2AC times the cosine of B. Cosine of this opposite angle. So B squared is equal to 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 109. Woo! Okay, that's kind of a lot, but I'm going to show you how you can just type that straight into your calculator. Okay, take a look here at this. I just transferred everything that I had on my screen here. B squared equals 10 squared plus 14 squared minus 2 times 10 times 14, all in parentheses, times cosine of 109. And I've typed it into Desmos. If you don't have Desmos, then you don't have the internet, and therefore you're not watching this video. Or if you have a calculator at home, you can do this all in your calculator, whatever calculator you have. Just type it in this way. 10 squared plus 14 squared minus 2 times 10 times 14 times cosine of 109, all in parentheses. The calculator will do order of operations for you. And I get 457.56. All right, so that must be my side length over here, right? No. B squared. See this? See this over here? This B squared? 457 point whatever is equal to B squared. So B squared is equal to 457 point blah, 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 blah. So in order to find the length of B, I'm going to need to square root 457.56, which gives me 21.4. So B is equal to 21.4. That side length is 21.4. Now notice, if I know this side is 21.4, if I needed to find these other angles, now I could use the law of sines. Because I have a side and an angle opposite that side. So once I use the law of cosines to find either one side or one angle, everything else I should be able to find using the law of sines. Okay, let's do another one real quick. So here I have angle A, and I have these corresponding sides over here. I'm trying to find BC, or with my little letter terms, that would be A. So A squared is equal to B squared plus C squared minus 2BC times the cosine of A. And again, you don't need to memorize that formula. You have that paper right there. So use that. A squared is equal to 15 squared. I'm going to put that in parentheses. I should put those in parentheses. Plus 29 squared minus 2 times 15 times 29 times the cosine of 135 degrees. So typing that in my calculator, 15 squared plus 29 squared minus 2 parentheses 15 parentheses 29 cosine of 135, I get A squared equals 1,681.18. But that can't be my side length. That doesn't even make sense in the context of this problem, so I have to square root 1,681.18, and I get A equals 41. A equals 41, and this is in feet. This was in feet. Notice now I have a side and an angle opposite that side. I could solve for a missing angle. The other missing angle is now using the law of sines. Okay. Let's see here. So here, notice I have a side, an angle, and a side again. So using the law of cosines, I will be able to find this side right here, side C. But that's not what I'm asked for. I'm asked for angle A. Well, in order to find an angle using the law of cosines, I need all three sides. So what I'm going to have to do is find this side, and then use the law of sines to find this angle. Okay, so law of cosine says C squared equals A squared plus B squared minus 2AB times the cosine of C. So C squared is equal to 21 squared plus 22 squared minus 2 times 21 times 22 times the cosine of 84. And again, typing that straight into your calculator just like that, whether you have my calculator types or if you're using Desmos, it doesn't matter. You should get 828, C squared being equal to 828.416. Square root that, and you get C is equal to 28.78 feet. So this side right here is 28.78 feet. Oh, but shoot, I wanted to find angle A. Well, never fear. Now I have a side and angle opposite that side, so I can use the law of sines. So remember, the law of sines says A over the sine of A is equal to B over the sine of B, which is equal to C over the sine of C. All those ratios are equal to each other. So I can take 28.78 divided by the sine of 84 is equal to 21 divided by the sine of A. Sine of 84 in my calculator, that reduces to 28.78 divided by 0.9945 equals 21 over the sine of A. Then I'm going to go ahead and cross multiply. So I'll get 28.78 times the sine of A is equal to 21 times 0.9945, which is 20.88. Next step, seems like a lot of steps. We're using two different laws all in one. Next step is I'm going to divide by 28.78 on both sides and be left with sine of A is equal to 20.88 divided by 28.78. I get 0.7257. And then to find A, I have to take the inverse sine of 0.7257. The inverse sine of 0.7257 is, and angle A is 46.5 degrees. Lots of math going on, so don't round your decimals super harshly until the very end. But that angle right there is going to be 46.5 degrees. And in order to find that angle, notice I use the law of cosines and I use the law of sines. So on some of these problems, as you're going through and as you're determining how to solve these, it's really going to become a dilemma of critical thinking. What tools do I have? Which tools do I need to use, and how do I need to use them in order to find the part of this triangle that I'm missing? Okay, we're going to skip this one for now. Now we're going to go on to some homework problems. Okay, we're about 15 minutes in. We're going to go over some homework problems. We haven't used the law of cosines formula where we have to solve for a missing angle yet, so we're going to get to that one over here. Okay, so this problem right here says find AB, this side right here. We can call that little c because it's opposite angle C. So since I have a side, an angle, and a side, I'm going to go ahead and use the law of cosines formula to find a missing side. C squared is equal to A squared plus B squared minus 2AB times the cosine of C. So that's 29 squared plus 27 squared minus 2 times 29 times 27 times the cosine of 111. So again, all of that I'm just going to type straight into my calculator. 29 squared plus 27 squared minus 2 parentheses 29 parentheses 27, parentheses 27 times cosine of 111. I get c squared is equal to 2131.20. Then to find c, I need to square root both sides. And when I square root both sides, I get 46.16. And this is in, to the nearest tenth, 46.2 inches. 46.2 inches, that's the length of this side right here, 46.2 inches. Okay, so that's number 1. Number 7. So number 7 says find measure of angle C right here. And I only know all 3 sides. So that second section there under the law of cosines, when we were talking about those formulas, gives you the rearranged law of cosine formula so we can solve for a missing angle. So to find measure of angle C, the measure of angle C, we're going to write the cosine of C is equal to A squared plus B squared minus C squared divided by 2AB. Notice I keep looking over at the formula sheet. I don't have these memorized. These are, I kind of do have them memorized. But it's not necessary to memorize them. Keep them handy and use them for reference. So I'm going to go ahead and write this down here. Cosine of C, down here, is equal to 18 squared plus 12 squared minus 16 squared. It's important that I make sure that the 16 is in the C spot because that's the one that's opposite angle C. Divided by 2 times A, which is 18, times B, which is 12. You can type this straight into your calculator too. You just need to make sure and put big parentheses around the top and big parentheses around the bottom. So I'm going to go ahead and my calculator type parentheses 18 squared plus 12 squared minus 16 squared, close parentheses, divided by, open parentheses, 2 parentheses 18 parentheses 12. Type it in exactly like that, and I get, let me draw a little arrow over here, cosine of C is equal to 0.4907. Well, that's the cosine of C. I need to find out what angle C is, so C is going to be the inverse cosine of 0.4907. An inverse cosine of 0.4907 ends up being 60.6 degrees. About 60.6 degrees. So this angle right here is 60.6 degrees. Found using the law of cosines. So don't hesitate to use all those parentheses in there. Type those in the calculator exactly as given, and you guys should be set. Remember, the law of cosines we use when we don't have already an angle and a side opposite where we could use the law of sines. Okay, let's do one more of these types of homework problems with finding the angles. So again, if I'm trying to find the measure of angle B, and I know all three of the sides here, cosine of angle B is going to be a squared plus c squared minus b squared all over 2 times a times c. Now I need to double check myself. Yes. Okay. So cosine of b then is going to be equal to, this is a, b, c, 11.7 squared plus 6.7 squared minus 15.1 squared divided by 2 times 11.7 times 6.7. Finding angle B here. So typing that in your calculator, make sure you have parentheses around both the top and the bottom. So 11.7, parentheses, 11.7 squared plus 6.7 squared minus 15.1 squared divided by parentheses 2, parentheses 11.7, parentheses 6.7. Close all those parentheses, and I get cosine of B is equal to negative 0.2949. Well, that's not my angle yet because I have to take the inverse cosine of negative 0.0 or negative 0.2949. So inverse cosine of that ends up being 107.1 degrees. Whoops. So this angle right here is 107.1 degrees. And we found that using the law of cosines. And now that we know this opposite angle, I know this angle and this side, I could, if I wanted to, use the law of sines to find all the rest of the missing parts. Okay, so this is homework problem number 13. Says, solve each triangle, round your answers to the nearest tenth. So I'm not given a specific thing I need to find. I want to find everything. All of the missing sides, all of the missing angles. So this is number 13. Let's do it. So I'm given a side and an angle and a side. So I don't know an angle and a side opposite that angle. So I can't use the law of sines. So I'm going to use the law of cosines. This is A, B, and C. So I can find this side opposite the angle with a squared equals b squared plus c squared minus 2bc times the cosine of a. So a squared is equal to 20 squared plus 14 squared minus 2 times 20 times 14 times the cosine of 93 degrees. I'm going to type that straight in my calculator. 20 squared plus 14 squared minus 2 parentheses 20 parentheses 14 cosine of 93. Close those parentheses. Make sure we're all set there. And I get a squared is equal to 625.308. That's not my side length. I have to square root that. The square root of 625.308 is 25. Call it 25. Round to the nearest tenth. So this is 25 feet. Okay, I'm going to erase this work. If you need to go back and look at it, just rewind this video a little bit. So that side length is 25. That's all fine and dandy, but I was asked to find everything. Well, now that I have this side and an angle opposite that side, I can use the law of sines to find everything else. So I know that 25 divided by the sine of 93 is going to be equal to, which angle do we want to solve for first? Let's solve for angle B. Is going to be equal to 20 divided by the sine of B. That's the law of sines. So the sine of 93, I'm going to write that as 25 divided by 0.9986 equals 20 divided by the sine of b. And then I'm going to cross multiply so I can get b by itself here in a minute. 25 times the sine of b is equal to 20 times 0.9986, which is 19.97. I'm going to divide by 25 on both sides. Sine of b is equal to 19.97 divided by 25, which is 0.7989. Then I need to take the inverse sine of 0.7989, and I get 53.0, round to the nearest tenth, 53.0 degrees. So this angle right here is 53 degrees. Note here for a moment, I could have used the law of cosines to find that angle. I could have, because now I have all the side lengths. Before I solved that, I had all the side lengths. I could use the law of cosines to find that angle, but in my opinion, it's easier to use the law of sines. So now I could, again, use the law of cosines or the law of sines to find this missing angle, or I could recognize that all the angles in a triangle have to add up to 180 degrees. So 180 minus 53 minus 93, 180 minus 53 minus 93 is 34. So this angle right here is 34 degrees. And that's every part of that triangle that I needed to find. We used the law of cosines, we used the law of sines, and we used our knowledge that all the angles inside of a triangle add up to 180 degrees. Now, if we're reflecting back to the beginning of this unit, now we could find the area of this triangle if we wanted to, using Heron's formula or the sine formula. And that's it. That's the end of this trigonometry unit. In the extra unit that's going to come next, we're going to have some real-world examples of using the law of sines and using the law of cosines. Some real-world examples where that comes in handy and where that becomes useful. But at the end of this video, I hope that you know what the law of sines is, not memorize, but that you can use it, and that you can use it to find a missing side length and find a missing angle. So I hope that was helpful. Please don't hesitate to reach out to me with any questions that you might have, any questions whatsoever, and I hope that you enjoyed that as much as I did.